Before we start the panel, I wanted to set the tone for this particular panel discussion. So I would request Ranit, Rana to make an ISSDA presentation on this particular panel discussion, so which will help the panelists, also the audience, to understand why we are organizing this particular panel discussion. And one of the reasons for doing this is in a positive way. What are the developmental areas that we can address on this rather than going into the negative things? So we always think positively. So how we can make Indian stainless steel industry geared up for the future requirement of railways in their rolling stocks. So that is what this panel is going to discuss about. And I would request Ranit, Rana to make this presentation.
Good afternoon, everybody. Good afternoon, ladies and gentlemen. The honorable dignitaries, both on and off the dais, and good afternoon, my friends. This is a topic, it's very close to our heart. And railways, whenever we hear this word railways, it evokes a lot of passion, it evokes a lot of nostalgia and memories. In fact, we cannot imagine our childhood without remembering our travels in a train. And therefore, because of these reasons, railways, the Bollywood industry has been particularly, enamored of Indian railways. And if I may take some examples, starting from Apu's trilogy in 1959 by Satyajit Ray, which catapulted him to global stardom. We have Mr. Amitabh Bachchan in iconic Coolies, Raj and Simran in DDLJ, Aditya Kashyap and Geet Dillon in Jab We Met, and of course, our beloved MS Dhoni. They all figure in some sort of way connected with railways. And it is because of this that Indian railways, have always stirred the heart of the nation. And in fact, Indian railways is the lifeline of this country. It is the world's fourth largest rail network, having almost 120,000 kilometers of track length. It runs over 13,000 passenger trains daily, carrying 23 million passengers on a daily basis. And it has a fleet of more than 3 lakh wagons and transports more than 1.5 billion tons of freight on a yearly basis. Now, we are extremely thankful to the stalwarts, to the railway stalwarts who are sitting on the dais, that they have preferred, stainless steel to be the material of fabrication for rolling stock. In fact, today, if we see all the passenger coaches that we have today, be it the Shatabdis, the Durontos, the Rajdanis, both long distance and, the short distance trains, they are all made out of stainless steel. All wagons, all the major wagons which carry iron ore and coal, they are all made out of stainless steel. In fact, when we look at the components, I would say almost 95 to 96% of the components today are made out of stainless steel. So thank you so much. In fact, we are deeply indebted to Indian Railways for having chosen stainless steel as the preferred material for Indian Railways. Now, going forward, Indian Railways has quite ambitious plans. In fact, they want to double the freight traffic by 2027. The Indian Railways wants to have more than 50% of the share of freight traffic by 2030. And over the next 2 years, almost 1 lakh of wagons would be procured. If you look at the number of coaches over the next 4 to 5 years, it stands to a staggering 40,000. So Indian Railways has embarked on a massive, expansion plan. And as we all know, wherever there is progress, there are challenges. And if we could, surmise these challenges, I would say that there are 3 S that we need to address. First and foremost is, of course, the safety. Second is savings, and third is sustainability. Safety and sustainability, they need no explanation. But whenever we talk of savings, there are 2 things which we need to keep in mind. One is, the longevity of the rolling stock, having minimal repair and maintenance cost. And secondly, and very critical, in fact, in today's context, is if you are able to lightweight those rolling stock, because that leads to enormous amount of savings in terms of energy consumption. So over these next few slides, I would try to objectively analyze that, in terms of material selection, how, the selection of a proper material could address all these three S. Talking about safety, the two most important criteria, both from the passenger and the freight point of view, are fire and crash resistance. When we talk about fire resistance, it means whether the material is able to withstand, higher temperatures, whether it's able to, keep its structural conditions alive even at very high temperatures. And when we look at the fire resistance properties of some of the materials which are currently being used, you will see that stainless steel has, it can exhibit high fire resistance properties even at 800 degrees centigrade. That means the structure is able to hold till 800 degrees centigrade, and that gives the extra amount of time for the passengers to be evacuated. If you look at carbon steel, the structural degradation starts from about 300 degrees centigrade. And if we look at aluminium, the various alloys of aluminium which are used for fabrication of rolling stock, the structural degradation starts from 150 degrees centigrade. If we look at the crash and the fatigue strength, well, if we compare stainless steel with aluminium, because it's also one of the materials for fabrication of rolling stock across the globe, we find that both in terms of fracture toughness as well as in terms of fatigue strength, stainless steel performs almost 3 times better as compared to aluminium. If we look at fatigue performance per se, then this is the SN curve, and as you can notice, for aluminium, there are no marked endurance limit. And what has been found globally is that with the fatigue strength of carbon steel, stainless steel, and aluminium, a carbon steel rolling stock, a train, can run for between 20 to 40 years. An aluminium rolling stock can last between 25 to 40 years. But when we talk about stainless steel, it can last up till 80 years. And this is a case which had happened last year. It happened in England, where almost 180 Hitachi-made aluminium trains had to be withdrawn from service. And what came out after the investigation was that it's primarily because of fatigue crack and corrosion, these trains had to be withdrawn. When we look at longevity, the most important characteristic is corrosion resistance. And while we are deeply grateful for Indian Railways for having converted all the major wagons which are carrying coal and iron ore into stainless steel, but there are still few wagons where we feel that stainless steel has a potential of it holds a good potential. For example, the BOST wagons, which are used for carrying coal and iron ore in the eastern region, the covered wagons. Then in terms of the components, the coach components, well, I'd said that 95% are today in stainless steel, but there are few more critical components which railways could possibly look at. One is the underframe, the second is the bogie frame. And why we are talking about corrosion resistance is because the country that we live in, and this graph is called the corrosion hut of India. India is a highly corrosive intensive country, and as you can see, almost 90 to 95% of the country falls under the corrosive zone. If you look at the coastal regions, the corrosion is extremely severe, more than 0.25 millimeters per year. But then even as we move inwards, the figures are substantially higher when we compare it to the other countries. And if I may quote from the International Zinc Association, they have mentioned that India loses around 5 to 7% of its GDP every year because of corrosion. And herein lies the uniqueness of stainless steel. Well, we have galvanized steel coated with zinc. We have a painted carbon steel, a painted cotton steel, and of course we have stainless steel. So, why would someone, pay almost 2 times the cost to go ahead with stainless steel? The reason being that, stainless steel exhibits a unique property, which is called the self-passivation characteristic. Now, in self-passivation, what happens, because of the chemistry of stainless steel, the chromium from the metal, it combines with the oxygen to form a corrosion preventive layer called chromium oxide. So as soon as this film gets broken due to any incidences, immediately the chromium reacts with the surrounding oxygen to reform this layer. And this is the reason why, the stainless steel gives the durability to the product. If we look at galvanized, a carbon steel coated with zinc, or a painted cotton steel, these are all physical coatings. And, during forming, during any kind of welding operations, from few, micro regions, these coatings start flaking off. And it is from these regions, the corrosion starts, and as soon as the corrosion starts, it becomes almost impossible to stop that. And that is, therein lies the uniqueness of stainless steel. And what lends this self-passivation characteristic to stainless steel? Well, we must remember that, stainless steels are alloys which contain minimum of 10.5% chromium. Anything less than that, they do not qualify as stainless steel. Because as you can see from the graph, when we have this 10.5% chromium, there is a, massive jump in the corrosion resistance of the material. Well, theoretically speaking, aluminum today is again, a point of discussion. And there is a belief that aluminum provides higher corrosion resistance as compared to stainless steel. Well, I would like to, disagree with that, because if we look at the electrogalvanic series, and we find that metals, which are towards the left, they are more noble. That means, they are more passive. Whereas metals falling to the right, they are more active, they are more prone to corrosion. And if you look at the position of aluminium vis-a-vis that of stainless steel, you will find that aluminium falls to the right of stainless steel. And therefore, the corrosion resistance of stainless steel is significantly higher than aluminium. And this fact is born, you can have this clear evidence of this when you look at the aluminium coaches. Globally, if you look at the aluminium coaches, all of them run in painted condition. Whereas, even in a corrosive country like India, if you look at the metro coaches made out of austenitic stainless steel, they run in unpainted form. So that is the reason, why stainless steel, it provides significantly higher corrosion resistance as compared to aluminium. There are few components, over the next few slides, I'll just touch upon 2 components where we feel, stainless steel holds an immense potential. One is, of course, the stainless steel underframe. Now, if you look at the photographs, these are stainless steel underframes of, these are the cotton steel underframes of LHB coaches. Currently, these underframes are made out of cotton steel, and this is the condition after 6 years of use. And when we interacted with the workshops, they mentioned that almost 3 to 4 lakhs of rupees is expended because of corrosion repair and maintenance. Now, we would like to thank RDSO. We would like to thank MCF because RDSO had taken the initiative, and they, recommended this grade SS201LN for underframe fabrication. And there are reasons why they had recommended this grade. One, it provides excellent corrosion resistance, and therefore, the underframes can have almost a maintenance-free life of around, 30-35 years. Other reason, if you look at the chemical composition, and I've compared 201LN with IRSM 41, that is cotton steel, you will find that because of the higher presence of manganese, the strength levels of this particular grade is higher as compared to cotton steel. If you look at the chromium content, the corrosion resistance of this grade is, I would say, 3 to 4 times higher. And, we have photographs which corroborate that fact. If you have, if you look at the nickel content, so higher nickel content means better formability. So these materials, lend, to better forming, are more amenable to forming. And of course, presence of copper and nitrogen, they increase the corrosion resistance as well. Not only corrosion resistance, from the safety perspective also, if you look at the impact resistance of 201LN vis-a-vis cotton steel, it's significantly higher, almost 2.5 times higher. If you look at the fire resistant characteristic, this particular grade can withstand temperatures up to 1000 degrees centigrade, whereas cotton steel can withstand temperatures about 500 to 600 degrees centigrade. I'll just give you, what is happening in terms of underframe. So we are extremely thankful to MCF, and Mr. Rawat is here today. We are extremely pleased to have him here because when he was the CPLE at MCF, he had taken the lead in development of, 100 sets of stainless steel underframes. And today, these 100 coaches with SS201LN underframes are running in the Western Division. And very recently, we did a joint inspection. Initially, RDSO had done this joint inspection, and then they also instructed us to have a joint inspection with the Coach Care Center in Mumbai Central. And what we could note is that in 70% of the cases, there was absolutely no problem with the stainless steel underframe. In the remaining 30%, it's only at the lavatory end, and I've shown the photograph over here, they could find traces of corrosion, not because of the material, but because of the weld spatter. So if you are able to address this spattering problem, if you are able to remove it, grind it, this entire underframe component would be free of rust. And we also, did a comparative analysis because we found several trains which were put on track in the same period as the stainless steel, as these coaches with stainless steel underframe. So after 2 years of use, you can see the, the condition of the cotton steel underframe. They have undergone significant corrosion. And in few cases, we also found, the flakes coming up from these cotton steel underframes. If you look at the commercials, well, we did kind of a calculation, the life cycle cost estimate based on, feedback taken from various workshops. And what we found out was that if Indian Railways adopt stainless steel underframes, then over a caudal life of 35 years, they could get a cost savings of almost 30 lakhs per coach. The other component, where we have been instructed by RCF to look into is in terms of the bogie frames, and we visited several carriage repair workshops, and what we found out was that after 9 to 10 years of use, they undergo significant corrosion. And if I understand correctly, as of now, RDSO doesn't have any provision for the repair of these bogie frames. So after 9 to 10 years, these bogie frames are discarded. So here again, we could explore high strength and corrosion-resistant stainless steel, so that we can get both the the advantages of weight reduction as well as a maintenance-free life of almost 30-35 years. And this is a photograph. This is a picture which I always cite, because many people ask that what is the guarantee that stainless steel is going to last for 35 years. So I take this example. This is the iconic Chrysler Tower, built in 1930s. So we are just 7 years short of a century. And over these 93 years, it needed to be cleaned only twice. And the grade which they used was 302, which today, have been supplanted by 304. But let me tell you, so in 1961 and 1995, so over these almost 100 years, it needed to be cleaned only twice, and that also, with a normal soap solution. So, we would like to assure Indian Railways that if you select the proper grade of stainless steel, if you select austenitic grade of stainless steel, you will gain both in terms of weight reduction as well as in terms of a maintenance-free life of almost 30 to 35 years. We've also, visited all the major wagon repair workshops, and as I had mentioned, there are few wagons, like the BOST wagons, where we see extensive corrosion happening after 10 to 11 years. And, again, here they incur about, 3 to 4 lakhs during this POH. We've also looked at, the covered wagons, because there is a belief that, since these wagons are covered, they do not undergo, corrosion. But let me tell you, even if they transport bagged commodities like cement, these are actual photographs which are taken after 25 years of use, and, they also undergoes significant amount of corrosion after 25 years. In fact, almost 70 to 80% of the material needs to be changed. So if you are, looking at increasing the caudal life of wagons, then, we would request Indian Railways to explore, stainless steel for these wagons as well. This is again a comparative study, which we did in conjunction with one of the major workshops, the wagon repair workshops in the country. And what we found out was, even after, if you look at the caudal, the code which is given on mentioned over here, it states that this stainless steel wagon was fabricated in 2009. And even after 13 to 14 years of use, there is absolutely no corrosion. And this was also endorsed by the Raipur Wagon Repair Workshop. They looked at a carbon steel wagon of the same period, and they found significant amount of corrosion happening, whereas in stainless steel wagons, even after 10 to 11 years, there are no traces of corrosion. This is, a case study of South Africa, where again, in fact, South Africa had been the pioneer in usage of ferritic stainless steel for wagons. And this wagon was fabricated in 1985. After 20 years of use, and you can see the photographs, they couldn't find any trace of corrosion anywhere. And what they have predicted is that the life of these wagons would be in excess of 50 years. Another critical, aspect is lightweighting, because, today we all read about the Vande Bharat trains. They are the future, and, going forward, over the next 4 to 5 years, Indian Railways has plans of fabricating, almost 8,200 stainless steel made Vande Bharat coaches. And lightweighting is a critical aspect for all these coaches. So what we did was, we tried to analyze that what could be the alternative stainless steel grades, because currently we are using the conventional ferritic grade, which is called X2CR Ni12. Now, if you look at X2CR Ni12, the mechanical properties, the yield strength is about 320 megapascal minimum. What we propose is that, why don't we look at high strength austenitic stainless steel, 201L, 301L, or, we could also look at lean duplex, because if you look at these high-strength austenitic grades, you can see the yield strength is 690 megapascal. They're almost twice as compared to the conventional used X2CR Ni12. If you look at the lean duplex, again, they are almost 70% higher in strength as compared to the conventional ferritic stainless steel. So, with such a high strength, the possibility of weight reduction is immense. And if you compare the chemistry, if you look at the chromium content, if you look at the nitrogen, which primarily contribute to the corrosion resistance of the product, both the austenitic stainless steel as well as the lean duplex, they contain significantly higher amount of chromium, as compared to X2CR Ni12. So therefore, if we explore the possibility of using these high-strength austenitic stainless steel grades, for fabrication of not only the coaches, but all the wagons as well, we can have a significant amount of weight reduction. We can have, almost a maintenance-free life for 30 to 35 years. Just wanted to share this slide. If you look at the aluminium alloys, if you look at the strength, they are roughly about, 245, 220 megapascal. Now, we also did a kind of an analysis that if we use this high-strength austenitic stainless steel grade and this lean duplex, what could be the possible weight reduction? And we found out that it's about 5 metric ton could be reduced. And if you look at the tenders which are being floated for Vande Bharat, there is a huge incentive for weight reduction. In fact, there is a 6 lakh incentive per metric ton weight reduction. And so if we can have, possibly 4 to 5 tons of weight reduction, the company can gain about 24 to 30 lakhs per coach, and the incremental cost would be about 5 to 6 lakh. Well, there is another tender which is coming up for wagons as well. These are called the new generation wagons. And if we understand, as we understand from RDSO and the Railway Board, they are looking at improving the critical parameters. For example, the pay-to-tear ratio would increase to about 4.7. There would be a reduction in tear weight. The volumetric capacity is going to increase. The axle load would be increased from 22.9 to 25 tons. And there is an increasing carrying capacity to more than 82 metric ton. And the mean distance between failure, it has been increased from 7.5 lakhs to 15 lakhs. So here also, if we look at these high-strength stainless steel grades, then, we can not only have weight reduction, but, we can also have, a kind of a maintenance-free caudal life of about 30 to 35 years. And finally, sustainability, we are all quite seized of this idea, and in fact, the whole world is seized of this idea. The temperature is rising. In fact, July has been the hottest month across the world. And as we see, with rise in global temperature, the carbon dioxide levels also keep on increasing. So it is also imperative that we also reduce the carbon footprint. And, Indian Railways, as always, they have taken the lead, and they have declared that by 2030, Indian Railways will be a net zero carbon emitter. And I would just like to, state that stainless steel is 100% recyclable material. It's a green material, and therefore more usage of stainless steel would enable railways to achieve their target faster. Some, articles, published articles, they compare the gross energy requirement, that is from cradle to gate production of stainless steel along with aluminium. I've highlighted aluminium because that's again a material which is in contention. And so both for the gross energy requirement for cradle to gate production, we find stainless steel to be better as compared to aluminium. Similarly, if you look at the global warming potential for cradle to gate production, again here also stainless steel scores over aluminium. And finally, just this last slide on what are the new trends which are coming up. Of course, we have the hydrogen train. We have Alstom, they are running this Coradia Lint in Germany. That's the first hydrogen train in the world. And it's also catching up in UK, France. We have the high-speed rail corridors, the Shinkansen, the bullet trains. And we would, of course, definitely like to hear from the railway experts as to what are the plans for India going forward. And finally, this is again a futuristic concept. I would say the Hyperloop. There are a lot of initiatives taken by IIT Madras and the MIT University in Pune, and we hope, and they have tied up with Indian Railways to develop the prototype Hyperloop. And we would also like to hear from our stalwarts as to what has been the development on this aspect as well. So with this, I would like to request the panel, the experts, to share their views and ideas on this topic. Thank you so much.
Thanks, Ranit, for the exhaustive presentation. Now I throw the questions, my views to the panelists. Actually, the stainless steel I was given to understand that it was first used for making coaches in 1938 or 39 in US, in Chicago. And Indian Railways started using it from year 2000 onwards. So with that, I first asked the view of the ICF, Mr. C.M.Rao, that importance of material selection for rail coaches, especially the Vande Bharat. So what are the primary considerations when choosing materials for rail coaches, and how do they impact performance and safety? And how does the choice of materials impact weight, energy efficiency, operational cost, and environmental concerns? So if you could throw some light on this. Thanks.
Hello? I think it's on. I'll try to give a small brief on, the trend of, basically for many of you it may be a matter of interest. What was the consumption of the stainless steel, particularly our coaching, particularly 3 main units put together? What has been produced in the last 3 years, and what could be this year and current year and the next year? See, basically, all the 3 units put together, the consumption, that is what has been purchased by these units for the in-house manufacture, as well as what has been purchased by the trade to supply us like the roof and walls and side walls, and maybe the floor sheet for the LHB coaches and our DPR stock, what we call EME memos. In 2021, it was 14,583 tons. 21-22, it is 22,920 tons. 22-23, it is 19,967 tons. All put together in the last 3 years, we have the consumption of stainless steel for the coach building by the Indian Railways, by all the 3 production units put together, it comes to around 57,469 tons. And they're going to be a good jump in the next 2 years. Basically, in the current year, the requirement of all the 3 units put together, as per the targets given by the railway board, it comes to somewhere around 54,146 in the current year, 23-24. And for the next year, that is the next financial year, 24-25, it comes to around 55,103 tons. There is a small, basically, roughly we are now manufacturing around, in totality, if you see that, at an average, if you see the last 3 years, roughly we are manufacturing around 480 DPR stock, all put together, I am telling you. And the major chunk is only the LHB coaches. Our mainstay, roughly around 5,500, we are manufacturing the LHB coaches. Put together, it roughly comes around 6,000. But slowly we are migrating from with the introduction of Vande Bharat and with more and more electrification. So there is a paradigm shift gradually to produce more and more DPR stock. So that way now we are if you see the next 2 years, you will find the LHB will come down to an average of 3,200 to 3,500. And there will be an increase in commensurately there will be increase in the EME stock. So basically that is how gradually in the next 2 years it will start to come down. But at the same time we are having an RSP sanctions. That means normally in the railway board they have a sanction of RSP. So this RSP is converted, they will give a lump sum RSP sanction. Subsequently it is divided into a production program and distributed to us in different production units. So we have, even if at the rate of 3,500 or 4,000 LHB coaches, we have an RSP sanction to come around next 3 years. At least we have a 12,000 RSP sanction is there in LHB coaches. You can see that at least based on the already what have been sanctioned, approved in the budget. So we will have, even if at the average of around 4,000 also LHB coaches, we'll have at least, there is a sanction already available next the 4 years to come. Similarly, now these RSP sanctions likely to increase for the Vande Bharat trains and EMU coaches also. And the existing current RSP available also, it will take care of next 3 years. Requirement at the increased, basically, there will be increase at an average this year itself now at an average of 500. The DPR stock EMU memos. This year, our target was to make around 840 or 850 coaches. So next year, it slightly may increase. Now, basically now, you must have seen our Vande Bharat trains now. ISF is rolling out 8-car Vande Bharat trains. Initially, we started with 16-car, and subsequently, we have started manufacturing 8-car trains. Right now, we are at the rate of, we are producing in the last couple of months at the rate of 5 trains per month, that is 5 8-car rakes per month. We are now coming close to turning out 6 8-car trains maybe in a couple of months. We have some hiccups are there regarding some important components. But otherwise, it's likely that we maybe by October, we'll be able to produce around 6 Vande Bharat trains. And our plans to produce a total of 64 trains of 8-car trains. Out of 75, we have a production plan of to produce 75 Vande Bharat trains of 16-car. But out of them, 32 will be made into 2 8-car trains. That is our production plan. Possibly by the October, we have a plan to complete 58 rakes. 58 rakes means 64 will be the 8-car trains, and further around 25, 26 16-car trains. We will be able to produce by the maybe July, August of
Mr. Rao,
next year.
One thing, what we wanted to know is, what is the criteria that goes behind in choosing the material for making Vande Bharat? So if you are given an option...
Material is, it is already specified in our specifications. There is no... See, basically even today, 80% we take from the trade only. 80% of our materials is from trade. But we specify the trade like, roughly if you see, I'll try to tell you also how much. If you see our LHB coaches, I'll tell you roof is concerned. Per coach I'm trying to say. See, overall if you see the SS409 constitute 80% of our LHB. In LHB, whatever we are using stainless steel, in LHB, we roughly use in LHB coach 7.3 tons of stainless steel. Out of the 7.3 tons of stainless steel, 80% is the SS409 grade. SS304 grade is only 18%. The remaining 2% consisting of SS316L. So these only we specify, and the traders are supposed to purchase from there. We don't insist that you purchase from XYZ. But mostly they purchase from Salem and other like Jindals and all that they purchase.
Thank you.
So we purchase very less because our in-house production is limited. So we only make some selective things, and the remaining we purchase from the trade in the form of a completely, we call it a shell kit. Means they completely give under frame, sidewall, end wall, and a roof they will give as a kit. Sometimes we also purchase a sidewall separately, roof separately, and wall separately, like that. So that way it is the manufacturer who chooses the customer, who meeting the requirement of the particular grade.
Thank you.
Yeah.
Now I will ask Mr. Bhutani, who's ex-DG RDSO, the role of stainless steel in achieving safety and efficiency goals, and how important is selecting high-strength, impact-resistant material for coaches and wagons. Insights into maintenance and life cycle cost associated with using stainless steel in rolling stock.
Good afternoon. In fact, the earlier part also, I think some of the parties not really answered. I will just like to throw some light on that. As far as planning of railway is concerned, we already have placed an order of 105 rakes of 16 car which is being produced by ICF at present, and MCF as well as RCF have also been given orders for turning out about 10 rakes of 16 car or 20 rakes of 8 car of Vande Bharat. Apart from it, 200 purchase order has recently been released for another 200 sets of sleeper version of Vande Bharat. And in addition to this, there are 2 more tenders. One is for 100 number of train sets with aluminum body. This will be suitable for a speed of 200 kmph. And the weight has been reduced in this, and about 30 to 35 ton reduction is expected by the manufacturer for supplying these rakes with aluminum body. And one more tender of 100 sets, which will not be exactly train sets. This will be loco-driven trains, which will again be suitable for running at 200 kmph. So this is the planning for train sets. And as far as material of these coaches is concerned, in fact, first 105 train sets, then 200 train sets, all of these are with stainless steel body. But we are really facing issue with the providing of sleepers in these coaches since axle load is expected to increase because sleepers are heavier version of coaches. So with sleeper, the axle load may increase. So this will be a challenge for us to really keep the axle load to the extent which is the borderline case in case of earlier version with the seating arrangement. There is urgent need for reducing the weight of trains as of now. Basically, when we check the total energy consumption of running of these trains, the present trains are taking about 20 units in hauling 1000 GTKM. That means this train is about 960 ton, so almost about 1000 ton each 16 car rake. So this will be taking about 1 unit in traveling 1 kilometer. 20 unit in traveling 1 kilometer. So that way, if it travels for 1,000 kilometer every day, so 20,000 units get consumed by Vande Bharat in every day. So these high-speed trains are definitely taking a lot of energy, and moreover, there is concern for reducing the weight of the trains so that there is a reduction in greenhouse gases, which has adverse impact on environment. Slowly and slowly, there is a lot of competition going on. Aluminum rakes are also there, as well as steel producers have also come up by giving better strength with the reduced weight. But the challenge remains that if we really reduce and make the section thinner and thinner, for example, I tell you that the LHP rakes, they had thickness of about 1.75 mm. So when we weld it with the side columns, so there is wrapping. You can see that the surface finish does not it got deteriorated because of waviness in the outside exteriors. So it does not look that good. So for example, in case of Vande Bharat, the thickness of wall is 3 mm. So, but the point remains that you increase the size, then the whole purpose get defeated. Means on one hand, you told us that the weight will be lesser if you provide stainless steel exteriors, but then a technology has to come with it. We definitely know that by skin tensioning, if you do the welding, then definitely these waviness and other things won't be there. But then the production capacity gets reduced. That gets compromised. So there are challenges. Means it is not that simple and straightforward if we say that whether it is stainless steel or aluminum. Moreover, there is debate going on, and definitely there is market for both the metals. Aluminum definitely has much lesser density. Means if you see the weight, it is almost 1/3. And as far as price is concerned, then it will be about 15 to 20% higher. But when we come to the energy consumption, whatsoever we feel like in case of high-speed trains, I don't want to discourage you, but fact remains all the high-speed trains of 250 kmph and above, they are mostly produced by aluminum composites. And in India, just a minute. I will just tell you that in India, we definitely know that these Vande Bharat trains are not going to go beyond 200 kmph. But don't you feel that India should have technology to really go for producing these high-speed trains? Means if suppose tomorrow challenge comes that India should also make 250 kmph and plus trains, should we not be having that technology at that time? So that is the reason, that is why we want to bleed at this stage itself. It is already late. I won't say that we should not try at all. There is a need to really develop technology for making high-speed coaches as well. But definitely, as far as Vande Bharat is concerned, I think maybe for next 10 years or so, stainless steel will remain the choice of manufacturing.
No, my point is, can the existing track take the load of speed of going up to 200 kilometers? Because you need to change the track also, no?
The biggest challenge in India, let me tell you that this Vande Bharat version 2.0 was developed under my tenure when I was Director General in RDSO. These trains are capable of clocking 200 kmph. They can go up to 200 kmph. There's no issue. The main issue is not the rolling stock. The main issue is cattle runover. In India, the biggest problem is cattle runover. Cattle crossing and unauthorized crossings and that kind of issues, they are really keeping us down. That is why we are not able to really increase the speed to 200 kmph. Otherwise, technology-wise, railway do have technology to go right up to 200 kmph. But fencing of track would be required. That is a long-drawn process so that there is no cattle runovers. This alone is the reason that for going for high-speed trains like 300 kmph and above, we have gone for grade separation. Means these trains will be on higher grade just like metros. That is why, but that is an costly proposition, but we have to really live with it. If you have to go for 300 kmph and above, there will be grade separation and this will be on elevated track in India. So present structure, maybe up to 160 kmph we are trying, and already work has been awarded and projects are under progress between Delhi to Bombay and Delhi to Calcutta.
Thank you, Mr. Bhutani. Now I come to RCF with respect to benefits of stainless steel in railway stock, rolling stock. What are the main advantages of using stainless steel compared to conventional materials in coach construction? And why is stainless steel considered the most suitable material for the formation of rolling stock in India? With the LHB perspective, if you could throw some light.
Good afternoon to all my fellow panelists and also the esteemed audience. I firstly thank ISSDA for having invited us here. We've had a wonderful first session. There were lots to learn. The speakers were absolutely fantastic. Now, because you see, a lot of people in the audience may not be fully aware about, we have been talking a lot of figures. Let me explain to you that Indian Railways has got 3 production units which manufacture coaches. One is the ICF, which is at Chennai. Second is the rail coach factory, which is at Kapurthala. And the third is the modern coach factory, which is at Raebareli. Now, these 3 units put together till last year were making between 6,000 and 6,500 coaches. This year, the target is 7,000 coaches. And next year's target is 7,800 plus coaches. So, as you can see, the number of coaches is going on increasing every year. And we expect that the requirement from production units will go on increasing in the next 5 to 10 years. And so there is a lot of opportunity available for the stainless steel industry. This is the first point which I would like to make. These figures which I am saying, giving you, is other than the tenders which are being issued by the Railway Board. One tender which has been awarded for 200 rakes. You must have heard about that from the papers. That is separate. And what Mr. Bhutani spoke about the aluminum rakes, that is also outside these figures which I am telling you. So there is wonderful opportunity for you. Second thing which I would like to mention to all of you is, you see, in the wagon industry, when we switched over from conventional steel to stainless steel, by a chance, by a coincidence, I used to be EDB freight at that time. I was associated with this decision to switch over from ordinary steel to stainless steel. And prior to that, I had experience of, in Jhansi workshop, I was the chief workshop manager, and we had seen the two types of steel together. We had some rehabilitation, etc. So as everybody knows, the basic advantage of stainless steel is the corrosion, anti-corrosion property which it has. And what I would like to say is that, you see, in railways, for any decision which we take, we do a very, very thorough cost-benefit analysis. A very, very thorough cost-benefit analysis is done. And at the time of the cost-benefit analysis, all the technical requirements, it is not only fatigue, it's not only toughness, it's also crashworthiness. You know, crashworthiness is also one of the very important factors which are taken into account whenever we select a material for switching over. So now, probably through several iterations which railways would have done at that time, they arrived at an optimum mix of stainless steel with ferritic stainless steel, say for the sidewalls, with austenitic seals for the roof and for the trough floor, and with cotton steel for the underframe. I mean, this I'm sure at that time, maybe in the, say, early 2000s, because LHB was first adopted in RCF. Rail Coach Factory was the first factory which got the TOT of LHB, and stainless steel was adopted first by RCF. So I'm sure that, through a detailed cost-benefit analysis and several iterations, this optimum, mix would have been worked out, which was probably relevant at that time. Now, a lot of ideas have been generated in this conference. I'm sure that all the panelists, very senior panelists who are here, they will go back with these ideas and maybe work on them. But all I would like to say is that whenever we want to switch, you see, the fact that we are using ferritic stainless steel and we are using austenitic on roof and top floor, because wherever we feel that water ingress will be more, where water will fall. For example, roof, water will fall on the roof. In the floor, when we are cleaning the floor with water will flow on that. So the roof and the trough floor are both austenitic stainless steel, and the sidewalls are ferritic stainless steel. You will all understand that ferritic stainless steel is approximately half the cost of austenitic, and then cotton steel is half the cost of ferritic stainless steel. So with a sort of optimum mix which railway has made, now whether we should go in for austenitic sidewalls, so what we would be doing is, we would do a detailed cost benefit analysis about if we go in for, because to my knowledge, in fact, even yesterday I was Principal Chief Mechanical Engineer in Western Railway for 3 years. We were doing POH of all LHB coaches. So in the sidewalls, there is no corrosion. Practically, there is no corrosion. If the corrosion is there, it is mostly in the underframe and the headstock area. So we would like to work out. In that direction, Railways has taken up this project, which was taken up by MCF, that 100 coaches were manufactured with similar sidewall and similar roof, but with a underframe which was of LN 201. Am I right? 201. So now these coaches are in service. They have not yet gone for the first periodic overhaul. Normally the coaches go for their first periodical overhaul after 3 years. They are still in service in the depots. They have already served for around 2 years. I'm sure that MCF and RDSO put together would be doing a detailed, analysis about how they are serving, whether their performance, because the performance probably, because even the coaches which had come out from, say, 2004 or 2005, my experience, at least in Western Railway, was that till 8 or 9 years, there was no corrosion, not much corrosion in the underframe. So I'm sure that the MCF and RDSO put together would be doing that. And as far as the benefits of stainless steel, I think everybody knows about the benefits of stainless steel. And that is why the railway switched over from box NHL to box NHL. In fact, it was mentioned that BCNs, but we have already switched over to BCNHL. BCNHL has become the major stock for railways. And we have selected stainless steel for our sidewalls and roofs and trough floor. The decision for also extending it to trough floor, to the underframe, will be taken in due course of time based on the cost-benefit analysis, which is being done by MCF and RDSO. Is it okay, Michael?
My next question to Mr. Arun, retrofitting and integration with respect to key consideration for existing railway coaches and wagons, and with stainless steel components and structures, and collaboration with railways operators and manufacturers of successful integration and deployment. One more thing, what I wanted to understand on this particular thing is corrosion is affecting everybody, and you know that there is it is affecting almost 6 to 8% of our existing GDP, which is crossing almost $110 billion. So how do you address this?
May I have your question?
Yeah.
Good afternoon to all. I'll again just read the question as it has been. Key consideration for retrofitting existing railway coaches and wagons with stainless steel component structures. So, sir, basically I will like to say here that our older wagons, basically wagons, they were of cotton steel. So there we have done a lot of retrofitment. Like the wagon bodies have been rebuilt. The underframe has remained same cotton steel, but the superstructure was made with the stainless steel. So that is called retrofitment. In case of wagons, it was done in a very large way. And not, I think it is going on for last more than 5 years or maybe 10 years. Now almost no wagon is left for retrofitment. So all our wagons are now, which are coming out, they have been manufactured fully stainless steel. Now coming to the railway coaches, I don't think that we do much of retrofitment, because that ICF coaches, as you know, that blue color coaches you must be seen. Those coaches were made from cotton steel. And the LHB is a red color coach. So they are made from stainless steel. There is not much of retrofitment done on ICF coaches. So we, as and when they are getting condemned, we condemn them. Of course, the underframe repairs in case of ICF coach is very high. So the workshops, we have experienced that. Whereas the LHB coaches, the repairs are comparatively less. So
are you considering using underframes of stainless steel in place of cotton steel?
Yeah, as it has been earlier told, that 100 coaches have been made with 100 coaches have been made with stainless steel underframe. Great. So we'll take a decision. Okay. There are a few ifs and buts. Probably one is of the basic what you call manufacturing, or what you call weldability. Fabrication is easy for cotton steel as compared to stainless steel. If you see even the stainless steel, we try to avoid welding. Wherever you weld, stainless steel those properties go away. So if you see in our LHB coach also, we have a lot of joints in the stainless steel where there are either spot welding or we do some kind of interlocking. So the interlocking and spot welding are the key methods of joining stainless steel. But when we go for welding fabrication, so it does affect the basic parent material. And the heavy underframe is a heavy structure. It's more than 5 mm thick sheets. Many sheets are 5 mm. So therefore, so far we are happy with the cotton steel underframe.
So some of our members in ISSDA, they are into welding of this thing of latest technologies. They claim that they can help in doing a professional welding on the stainless steel also. So I was wondering whether ISSDA could sign an MOU with RCF and ICF in providing the requisite training from the multinationals, who claim that they can do so as an initiative to make it.
Ashesh, this is a good proposal.
I think, you see, let me tell the august audience over here that please don't underestimate our production units. Rail coach factory, Kapurthala, has received the IRIS. You see, I don't know how many of you know about IRIS. IRIS is the International Certificate for Railway Industries. Only 118 companies worldwide have got IRIS Silver Certificate. Rail coach factory, Kapurthala, has got IRIS Silver Certificate. We've got the IRIS Silver Certificate, and we have fantastic welders. And we have also got the certification for welding. So as far as we are concerned, I don't think there's absolutely any problem in welding, at least in rail coach factory. I can say confidently that the welders which we have in rail coach factory, they are not second to anybody in the world.
Oh, great.
We have got IRIS Silver, and you see, this has been certified by an international body.
Okay.
And only 118 companies in the world have got IRIS Silver Certificate. Around 2,000 have got bronze, but only 118 have got IRIS Silver Certificate.
No, thank you for this insight. Why this question was asked was, we had an interaction with ICF also. So where, we suggested this and they welcomed that idea. So I was wondering, if it could help.
No, I'll just add it. See, from viewpoint of skills of the operators, we don't lack. That is very good in RCF. But yes, technology-wise, if people are there to give some technology, they're welcome.
Yeah, we are always welcome to ideas. We are always welcome to ideas.
That's what I wanted.
Yeah. I meant to say, from this forum, I can say that if there are some welding techniques which you want to showcase, please do come to RCF, and we will show you our facilities and where we can collaborate. Those things can be decided.
Great. Thanks.
And second point you said was regarding collaboration with railway operators. I think it's a new concept which is gradually developing now. Like earlier, so far, railway trains were being maintained by railways. There is now, like, we are going to purchase full trains, and those trains will be maintained and operated by the private players. So that concept is yet to come. I think I don't have that much of what you call qualification to comment about it, but it will come.
Thank you.
Thank you.
My next question to Mr. S.K. Rawat. This is regarding challenges and quality assurances. So challenges associated with the fabrication and assembly of stainless steel components for railway coaches. I want you to address this because so that our members can be future ready or understand what are the issues that you have so that they can come with a solution. And second thing is ensuring quality in stainless steel components for railway rolling stock.
Okay. First of all, I would like to thank Mr. Rajamani Krishnamurti, President, Indian Stainless Steel Development Association, and Mr. Ranit Rana, AVP, Jindal, for inviting us for this wonderful interaction and giving us opportunity to interact with you. Before answering this question, just an overview regarding the opportunities for stainless steel, which are basically coming up because of the policy changes in Indian Railways. Now there is a lot of focus on the freight trains. Hungry for cargo is a mission of Indian Railways, and say by 2030, that means in next 5-6 years, presently our wagon fleet is around 3.5 lakh wagons. It is likely to be just doubled. The requirement has been projected as 6 lakh wagons by 2030. So that means another 3 lakh wagon will be added they will be newly manufactured by the Indian industry, because all the wagon manufacturing is being done in a private sector. So, and even like box and HL wagon, which is fully stainless steel wagon, it is having around say 10 metric ton of stainless steel. And some other wagons are having 5 or 6 tons. So even if we take average of 5 metric ton per wagon, so 5 into 3 lakhs. So that is the requirement of stainless steel which will be required, and regarding wagon operations. Mr. Rana has also touched upon in his presentation regarding the new wagon. So I'd like to elaborate that even the Railway Board is having a new wagon policy, and board is coming up with procurement of 50,000 wagons, in which you have to bring your own design. The requirement has been spelled out like pay to tear ratio, or the speed, or the gauge, and some other parameter like axle load for bearings. But the suspension, the material choice, the design, the drawing, etc., that the industry can come out. So although we are sitting with stainless steel manufacturers, but what I would like to say that you should also collaborate with some of the wagon manufacturers of Indian make, or even abroad with some Indian joint venture or something like that. Jindal is already there because they produce steel as well as they are having one wagon manufacturing unit also. So others can also come out. You can offer your own design, and in that new policy, even the role of RDSO is sort of minimized. Like in ISSDA, you have to engage ISSDA, they will be evaluating your drawing. Once you make the prototype, it will be evaluated by the ISA. Then you have to do the series production. Wagons will be run on Indian Railways, and you have to maintain also. Even the maintenance of the wagon for the entire caudal life of say around 30-35 years, it is being left to the industry. So a lot of opening up is coming up. So this is the opportunity to offer better material, better freight cars for the Indian Railways. As you are aware that mostly the railway earnings are only through the freight operations. So anything in the freight is a good opportunity for the industry. They can come out. Regarding coaches, GMRCF has already elaborated in detail, like our production plan which is issued by the board, LHV and MEMU coaches, 7,000 to 8,000 coaches per year. Mostly they have planned to phase out all the ICF coaches. So LHP will be there and they will continue to be manufactured. Of course, more and more train sets are also coming up. So again, the requirement of stainless steel is there, and the components also. A lot of components which are fitted in the undergear. Most of them are stainless steel. Regarding underframe, so they were fitted in January 21, I think. So in next 6 months, they will be completing their PH cycle. So they will come for PH in say one of the Western Railway workshops. So at that time, I request that industry should also, they can also come out along with the RDSO and MCF. They will be studying the effect, and then the further decision can be taken. Because if because underframe is, the weight of the underframe is say around something like 6 tons. So 6 ton per coach, and if we are making 7,000 to 8,000 coaches per month, so it is a big thing. So another one thing I would like to say is, since we have also mentioned about the cost effectiveness and all the analysis that in the minimum cost railway gets the best product which serves the purpose. So I would also like and request industry, the stainless steel manufacturers, that you should also move forward and get into touch with the component manufacturers, those who are actually making the underframes or the complete shell kit and supplying it to the, because you directly don't quote. If we call for the shell kits, the tender is for the shell kits, then Jindal or anybody is not participating. The underframe manufacturers, approved sources are participating. So you have to sit with them, work out the cost so that railway gets the competitive price at the minimum cost and the good product, if at all we decides to go for it in a long way. And that is one thing. Second thing is regarding this life cycle costing, which Mr. Rana has showed. I'll request him to again rework the calculations with RDSO, I think. Because I think it is mentioned that in every POH, in 35 years of POH, 35 lakh rupees will be saved in corrosion. So that means every year 1 lakh per corrosion. So that actually it should be worked out with the, in collaboration with the workshops, good workshops. Remove all the overheads, because costing of different workshops will be different because of the other overheads. So actually work out the manpower, man hours, and you have to do some more study, rigorous study in cooperation with RDSO and the workshops, CWMs. And then only the real picture will come out. So these things are there. Stainless steel weldability, industry has, I would like to say that they have, I think Indian industry is matured enough, because we are not seeing much quality issues, be it a retention tank or some side wall or end walls. Some, because of smaller sections in the roof, some small holes on the roof or water leakage on the roofs, all those are things are there which are tested at the firm's end only, and they get rectified. So I think more qualified welder. In fact, now in the industry, it is one good thing is there, that now the training is being given the due importance. And so I would like to request that all the industry representatives, that regarding the quality of skill development and quality of work, more and more focus should be there for sustainability, for long-term association with the railways. And if you make one first time right, then definitely the cost is less. So although this part earlier was, I would like to say, not given so importance, but these days you have to have good welders, good machines. You have to incur in the skill development. There are courses. Even the government of India is also running many courses. Even industry associations are running such skill developmental programs. Even in this north region, I am aware of it. So I think you people, even the Stainless Steel Manufacturers Association, you should also come forward and organize such courses voluntarily for skill development of the welders in the clusters, basically rail ancillary units. There you should go and find out the skill and try to improve. So once we work in a holistic way, then I think it will be a win-win situation for the Indian Railways as well as for the industry. Thank you.
Thank you, Mr. Rawat. My question to now corporate, now sustainability and environmental impact is the buzzword today, and everyone wants to achieve a net zero carbon emissions. And there are, measures like CBAM and all those stuff. So how industry is geared up to take this challenge and ensure supply in accordance with this?
Good afternoon. Thank you for giving this opportunity. Yeah, I was listening all the panelists, and it is enlightening to me to understand nice presentation by JSL. As far as sustainability and green steel is concerned, in Steel Authority of India, particularly two plants, one our realized steel plant in Dugapur and Salem Stainless Steel, where we use the electric arc furnace route, where completely we are using the recycling, and we produce steel from the, scrap.
Great.
So we are working towards that. Even scope 1, scope 2, scope 3 also, we are trying to improve upon it. Like we are trying to invest on solar energy. Like for example, Salem Steel Plant, we are planning to install a solar energy plant for 50 megawatt. And more and more usage of stainless steel scrap and mild steel scrap in producing this steel, so that ensure the entire recycling and minimum carbon emission. So in all levels, we are taking Salem Steel Plant and LI Steel Plant as a model plants in Steel Authority of India to achieve this green steel and sustainability.
Thank you. My last question to the panel is especially ICF, RCF and RDSO. How to tap the export potential for coaches and wagons? Are we geared up to tap this?
You see, from RCS perspective, the first thing which I would like to mention is that railways itself has got such a huge demand for coaches. For example, in my factory, the installed capacity was 1,000 in the beginning, then it was increased to 1,500. Against 1,500, now we are already manufacturing 1,800 coaches. So that is one issue which we have. But other than that, we have already participated in a tender for one of the countries, one of our neighboring countries. And let us see if we get their order. Definitely we are interested in, we would definitely be interested in export.
ISF regularly exports, coaches. We take normally order through rights. Rights our, public sector undertaking of Indian Railways. So last 2 years we have exported mainline coaches to Sri Lanka. And apart from diesel demos, what we call diesel multiple units to Sri Lanka, recently, last 2 years. Apart from that, we have also sent the first, I think, Nepal doesn't have a railway line also. So Indian Railway constructed one railway line, and also there we are running one demo diesel multiple unit. And basically that we can say that Indian Railway, other production units, trying to compete with Chinese mostly. So there was we used to export to Sri Lanka and Bangladesh. In between, the Chinese competition has come and we are not able to match the price. And slowly they found that also the quality of the Chinese also not up to the mark. So then finally their rates have increased and we are able to match the rates and we are getting the orders. And apart from that, now with the Vande Bharat Express also, we recently had a inquiry from Chile for they wanted to purchase, and similarly some Bangladesh also, some team has come. Honorable Minister of Railways from Bangladesh also has recently visited. They wanted to give a big order, but actually we don't have that much capacity right now. We are fully packed with our Vande Bharat Express production. You told them the current year, maybe next year, we will not able to take up. That way we can say that Indian Railway production units, they are geared up to exports, and there is an export potential and there is a demand also from the neighboring countries. Mostly it is from Nepal and maybe now the new avenue is the Sri Lanka, Nepal and Bangladesh. These are the three countries normally we export coaches. And maybe with the Vande Bharat Express trains being popular elsewhere also, now we are getting inquiries mostly. We are expecting that there will be some export orders once our Indian Railway commitments are over. I would like to add one thing, like our retired DG Saab has told. See, apart from this, now we are producing around 115 trains of train sets right now within our railways, between our 3 production units. And order is already given for 200 train sets for stainless steel car body only. Plus 100 more, this is push-pull train, what we call it, loco-hauled train set. The 100 is, I think, in the annual for the tender. So this is all stainless steel, but only 100 numbers aluminum car body The tender is in the finalization. I think Mrs. Alstam happened to be the lowest one. Apart from this, now the ICF has been, in the production program, they have been asked, ICF has been asked to produce 200 more train sets. So basically we are like ICF, then some of them will go to RCF and MCF also, out of these 200. So shortly ICF will likely to float a tender for the electrics and others for 200 more train sets. All of them will be only stainless steel car body. So if they put together whatever the visibility range, we can say that, so whatever has been already sanctioned 115, you have around 300 plus 200, 500 more train sets are likely to be produced. And like our colleague Rawat is telling, you must have seen recently the Indian Railways awarded a huge contract for 1 lakh wagons, okay, almost. Out of that one wagon, you are aware, very popular wagon, which we call it as box in HL, 22.9 axle ton load. This is purely a stainless steel wagon. So basically there each wagon is, next 3 years, I think we are supposed to produce, the industry is supposed to produce roughly around 45,000 wagons at the rate of 15,000 wagons per annum. And each itself, I think 10 tons each is the stainless steel content in that. Possibly it itself gives you, if you see the overall calculation, I can see that the requirement will be almost, from the freight stock, it will be roughly around 15 into 10, maybe 1.5 lakh tons from the freight cars of box and HL alone, plus around 50,000 tons from our coaching stock. I can see there is a potential of 2 lakhs average, the potential of consumption by the rolling stock of Indian Railways, both freight cars and these cars per annum in the next 3 years to come, at least minimum.
So thank you. With this, we conclude this panel discussion. I thank all the panelists for taking their time out. And one thing we have come to know that there is a great potential for stainless steel into the railways sector. Apart from coaches and wagons, we can go for underframes, we can go for cable trays and station development and other things. So now I open the floor for questions to the panelists. Thanks. Yeah, please.
Can I ask one question from sitting in the plenary?
Madam, you can take this.
Yeah. I have a question to
Hello.
the people. Yeah.
Hello, may I speak? Yeah, question for GM RCF. Has Indian Railways examined the feasibility of using stainless steel for Fiat bogie frames?
Sir, as you know, the projects are normally allotted by Railway Board, but I am not aware of such a project. At least for RCF, we don't have any project like this. But definitely we can, on our own, do a study on this.
Maybe MCF can answer. They went in for stainless steel for the coach underframes. Did you also think of using it for bogie frames?
Sir, the bogie section is still thicker than the underframe. As I told you earlier, it's even more difficult prospect to use stainless steel for bogie. It's a fabrication, sir. Your fabrication has to be MS. Stainless steel is not a good material for fabrication.
So with that, we conclude this session. I thank all the panelists. Any other question? Yeah.
You see, one of the main issues which is affecting the consumption of stainless steel in India, if you see the presentation which was done by the first panelist from ISSDA.
Yeah.
You know, the cost of cotton steel and the cost of 201 LN steel, the difference is huge. What the industry is doing to reduce this cost? Because another aspect is, we were comparing the prices of Chinese steel, similar quality steel which is used in wagons, as compared to what is available to us from JSL. This was in connection with an export potential by our company in an African market. And we found the price difference is huge, something like about 30 rupees per kg. Now, is the industry working towards that? Matlab, why do we keep on coming to government, give us SOPs, give us anti-dumping duty and everything? But the cost reduction which is possible in our country, why that is not, aspect is not giving adequate attention? Because if you do that, then stainless steel will automatically win over all other steels. You don't have to go and market yourself.
Yeah. Here, one thing is capability of producing steel. Okay, within our steel manufacturing industry, we got a complete capability, complete range of production. Whatever sections, whatever grades, everything can be manufactured. And coming to your question of cheaper material from China and other countries, vis-a-vis Indian. So exactly as per as production cost, as per as raw material consumption, as per as techno-economic parameters are concerned, we are at par, and at certain levels, we are better than international standards. Yes, having said that, why you are costly? It is not the industry, that is the stainless steel manufacturing industry alone can control the price or cost, because when you are comparing with China, there are so many hidden benefits given, whether it is power tariff, whether it is export benefits, whether it is given cross subsidies, with so many benefits available from Chinese market, and with the emphasis of Make in India here. So particularly for me, for a public sector representing the Steel Authority of India, I am invariably has to buy most of the material from India only. Whereas for people like some wagon builders, as you are telling that it is cheaper imports are available. Yes, if we are asking anti-dumping, we are asking CVD, ADD, not to support our inefficiencies. Basically, it is to counter the cross subsidies and the other benefits given to the Chinese companies, where they have got the excess production more than what they can consume, whether it is China or whether Indonesia, and producing more quantities and dumping into Indian market. Definitely take it from me, it is not to hide any of our inefficiencies. Anything you want to add?
Yeah, with this, I think we are running late, so I close this session, and I thank all the panelists for sparing their valuable time, because we have to start our next session immediately, and we have a CEO's roundtable also lined up with Secretary Steel at 4 o'clock. So any questions that you have, you may just send it to ISSDA. We will get it answered through the panelists. Thank you. I would like to have a big round of applause to all the panelists.